Hello programmers, welcome to the video. So today we will be solving day 14 of October Leetcode challenge, daily challenge. So today's question is adjacent increasing subarray detection 1. It's a easy kind of problem. So another lucky day, we are getting easy problems. Okay, let's directly jump into the problem and try to understand what is the problem here. So given an array nums of n integers and a k. Okay, we have given n nums array and we have a integer k. Okay, length of these nums is n. Okay, determine whether there exist two adjacent subarrays of length k. What is subarray? Subarray is a continuous. Okay, subarray of length k such that both subarrays are strictly increasing. Strictly, specifically check if there are two subarrays starting at index a and b, a less than b, where both subarrays a to ak minus 1 and nums b to bk minus 1 are strictly increasing. The arrays must be adjacent, meaning b equal to a plus k, and return true if it is possible to find two such subarrays and false otherwise. Okay, so let me take my pen and let's understand this better with some examples. So here example number 1 is given 2 5 7 8 9 2 3 4 3 1 something kind of. Okay, and we have k equal to 3 and it is returning true because we have a increasing subarray 7 8 9. Yeah, we have 7 8 9 and we have 2 3 4. We have 2 3 4. It's both of the length is 3 length array, 3 length subarray, and both are strictly increasing. What is the strictly increasing means element of I should be less than of element I plus 1 should be less than of element of I plus 2, something like this. Okay, till I plus k less than dot I plus k. Okay, if this condition meets, we say that it's a strictly increasing subarray. Why at k? Because we want this length to be k. Okay, the second example is saying 1 2 3 4. Okay, then 4 4 4, then 5 6 7, and it is k equal to 5. So we are not able to find length of 5 and then length of 5. Okay, so we need at least 2 n elements, right? 2k elements. So we have k equal to, let's say, 1. So at least we need 2 elements in the array. N should be equal to 2. If n is less than this 2k, so if n is less than 2k, then obviously we didn't able to find, we can return false directly. Okay, because we need 2 elements, right? If k equal to 5, then at least we need 10 elements. N should be greater than equal to 10, right? Otherwise, so how can we find subarray of 5 elements strictly increasing, then subarray of 5 strictly increasing, and then both of them are like adjacent? This element ends and this element starts just after that. This is the adjacency means. Okay, so let's look at the constraints once. So constraints are given like nums of length less greater than equal to 2. Yes, if k is 1, then obviously we need 2 length, and 2k should be less than nums of length and greater than 1. If k is 1, then 2k will be 2. So it will be starting from 2 up to nums of length. Okay, 2k should be like maximum of nums of length, and numbers are minus 1000 to plus 1000 given. Okay, let's think about how can we solve this problem. So let me try run on the second example why it is the case that it is not a array of 5 increasing. Okay, so let's say we have 1 here, then we have an increased number. So I'll like to draw this in a mountain and dip kind of pattern. So I will explain what it is. So this is 1, then 2 is above that 1, so it is like next element. So I have drawn it, like pointed it next to 1, but I have pointed it higher because it's a higher value. So this is 2, then we have 3, then we have 4. Okay, so we have 4 elements continuously increasing. We found that these 4 elements are continuously increasing. Okay, didn't find 5. Okay, next is 4 again. So it's not continuously increasing, it's like similar element. Okay, and here if it is not continuously increasing, our count reset. Okay, so after that we have 4 again, then 4 again, then 4 again, something like that. Then we start getting like 5, then 6, then 7. So we will be getting 5 6 4 5 6 7, this 4 length of array again. Okay, this 4, then this 4. Got it. So can we count if it is strictly increasing, like it's 1 2 3 4, the length. Okay, length of the strictly increasing till here. Okay, So what I mean by that, let's say we have an example 1 2 3 4 5 6 7 8. Okay, it's a strictly increasing array, it's a completely strictly increasing array. Okay, if I say find array with k equal to 2, can you find? Yes, because 1 comma 2 is strictly increasing, 3 comma 4 is strictly increasing, and both are adjacent. If I say, let's say k equal to 3, find. So can I find? Yes, 1 to 3 is strictly increasing, then 4 5 6 continuously increasing, and both of them are adjacent. Okay, it's not necessary that we have to go up and then dip and then go up. It's not necessary that this element of b should be less than a plus k minus 1. Okay, this is a plus k minus 1, this is eighth element. So total a element, k element is there. B element can be bigger than or equal to this a plus k minus 1 element. Okay, so there is no condition, it can be equal, can be bigger, it just have to be like increasing next k element. This k element should be increasing and then next k element should be increasing. Okay, great. So how I am thinking in my mind, I will change my color, paint color. Okay, let's think about it something like this. So we have 1 2 3 4 5 6 7 8. Okay, so I will make an array, I will make another array in which I will store the increasing length. Okay, so till here, if I have seen here, what's the length of increasing sub arrays? Obviously 1. Okay, this is the only element. Okay, now I have expanded my search space till 2. So in 1 2, what's the at the 2 I am standing at 2, what's the length of increasing sub arrays? Okay, so it's 2 length, 1 comma 2. Okay, at 3, what's the length? 1 comma 2 comma 3, it's continuously increasing till 3. So at 3 I can certainly say I found an sub array with size 3 which is strictly increasing. Correct? At 4 we have 4 5 6 7 8, it will be calculated like this. Let's say after that I have 8 again, and then I have 9 10 11 12, something like this. Okay, so what will be our answer for going forward? At this 8, what is the length of strictly increasing sub array just before from that? Okay, so it's 1 only, because this is the element. If I look back, it's same element, so it's not strictly increasing, I can't include this element, so this is 1 only. Okay, then this is 8 9, we have 1 comma 2 2, then 3, then 4, then 5, this kind of thing. Okay, now I need to find a stuff, I need to find a substring which is like k equal to 4. This is given like k equal to 4, find if there is exist anything or not. At k equal to 4 we have to find if there exists any number which is like 4 length of strictly increasing, then 4 length of strictly increasing. Okay, so how can we find in this array? If I, let's say, build this array, it's simple, I just look back and plus 1 in the element if it is smaller, if it is similar, or if it is bigger, then I will reset it to 1. Okay, so it's easy to compute. Let's say how to calculate for k equal to 4. Okay, so we need to find, there should be 4 elements which is like strictly increasing, and then it should be adjacent to another 4 elements. Okay, so I can traverse this array, and I will say that at this point, let me change my color. Okay, at this point, at this 4, I found a array, I found a array which is, I found a sub array basically, sorry, I found a sub array which is of length 4, okay, which is of length 4, and it is strictly increasing, it's a strictly increasing. Okay, then I have to just check that adjacent array of this k element should be greater than equal to 4. Correct. So I check that if this array of this pointer, like this is let's say a, this pointer is a plus k minus 1, next pointer is b, and this is b plus k minus 1. Okay, b plus k minus 1. So I will check from here that if I have k elements, I will jump k steps simply. Okay, if I jump k steps, I will reach here. Correct. If I jump 4 step 1 2 3 4, I will reach here. If this I plus kth element of this calculation, let's say calculated array, if it is greater than equal to 4, means I found 4 length array. Okay, I found at least 4 length array. If it is 5 6, doesn't matter, in this case it's 8, doesn't matter, it's bigger. So I found this strictly increasing of 4, then strictly increasing of 4 elements. This way I can find. Correct? Okay. Great. So I hope you understood this. Let me quickly try run on this both of the example our algorithm just to test that we are correct. Okay. So at 2 we will create an array first of all. At 2 we will start with 1. Okay. At 5 it's increasing, so I will make it 2. At 7 it's still increasing, plus 1 3, then 4, then 5. Okay, then we have 2 again, so it's reset to 1. Okay, because it's not strictly increasing now. Then 3 4, so we have 2 comma 3 strictly increasing till here, then it's reset again. 3 is less than 4, so it will be reset again to 1 length, and then 1 is less than 3, so it will reset again to 1. Okay, this is calculations. Now k equal to 3, we have to calculate for k equal to 3. We will search for k greater than equal to 3 element. I found here. If I check after jumping k step, like 1 step, 2 step, 3 steps, did I find anything which is greater than 3? No. Go ahead, go to here. Is this greater than equal to 3? Yes. At this present its element, like let me call it element, is greater than equal to k. So I am here. I will jump k steps, 1 2 3. Okay, 1 2 3, so I will reach here. Let me change my color. Yeah, I will reach at this road. Is 2 greater than equal to k? No. So that's why it's not answer here. I didn't find the answer till here. Okay, next I will go to here. Here I have element greater than equal to k, correct. I will jump 3 steps, 1 step, 2 step, 3 step. I will reach at 3. Is it 3 greater than equal to k? Yes, it is greater than. So I found this is a 5 length. I will just take 3 lengths of this, and this is 3 length again, and both of them are adjacent. That's why I jump just only k elements, k jump only, to find that it's adjacent or not. I can like go ahead and check if it is greater than. I might find, but there is no use case, right? It will not be adjacent. Okay, so it's I think algorithm is simple and easy to understand. Let's quickly code it. And equal to nums dot size. Okay, and we will be building a vector of int in which we will check increasing subarray length. Okay, let me make it increasing subarray only. I will make it till n length, and I will make it to 1. Okay, at least 1 we have. If I am resetting, then also I have till 1. Okay, so I will be looping through I equal to 1. I will start with 1 because at I equal to 0 it's obviously 1. It's already set in default values. Okay, for I equal to 1, I less than n, I plus plus. Okay, if my nums of I is strictly greater than nums of I minus 1, then what I will do, I will add increasing subarray of I equal to increasing subarray of I minus 1 plus 1, previous element plus 1, correct. Otherwise it will be reset to 1. So it's base case handled already. Okay, great. Now I have array. I will loop through this array again. Entire average 0, I less than n, I plus plus. Okay, if I found an array element, if I found a nums of I, if I find nums of I is greater than equal to k, then we will check if it is worth it or not. Else otherwise, so we don't have to check anything. If it is greater than equal to k, what we will check? We will check nums of I plus k. I will jump k elements should be greater than equal to k, right? I will jump k elements, and this also should be greater than equal to k. Great. Okay, so I will check this condition also in and then here. Then I will return true that yes, I found it. Otherwise I will return false. Return false. Here we need to make sure on one thing, that if I am doing I plus k should be defined, right? So I will write n minus k till here. I will loop through n minus k, so it will be I plus k will always be defined. Okay, so let's try to run this code. It's fairly easy and simple. Yeah, and both the test cases are accepted. Let's submit this code. we found a wrong answer. We have minus 9, 15 and 19, which is like 2 size. Okay, so let's debug it by why is the case. Then we have k equal to 1, we have k equal to 1. Okay, 1 I will always find it. Okay, so I will start with 19. Nums of I is greater than equal to nums of I minus, correct. So increasing array is increasing array minus 1 plus 1, so it will be 1 2. Okay. So we will be getting array of 1 comma 2. Great. After that we will loop it through till n minus k. Okay, so what is n here? N is equal to 2 here and k equal to 1 here. So n minus k will be like 1. Okay, and less than equal to, I have to find till n minus k. Now I have to loop 0 and 1 as well, right? Otherwise, so there is, I don't think so. Okay, 0 1, sorry, and if it is less than 1 it will run for 0. If nums of I, oh, I don't have to check on nums of I, no, I have to check on increasing subarray of I. That's the mistake. Let's try to run this code again. Oh, let me comment it. It's a debug code. Yeah, it's accepted. Now let's submit it. Strange, 708 test cases passed without doing anything. Okay, great. So it's submitted. We have now 17 day streak. Well done. Great. So let's meet tomorrow for the next question. I hope we will be solving some challenging question tomorrow. Hope to see you. Bye.